The function f is defined for x greater than 0 by fx equals log x, and the function g is defined for all real values of x by g of x equals x squared plus 8. Find the exact positive value of x satisfies the equation f of g of x equals 8. State which one of f and g has an inverse, and define that inverse function. Find the exact value of the gradient of the curve y equals g of f of x at the point with x coordinate e cubed. Use Simpson's rule with 4 strips to find an approximate value for this integral, giving your answer correct to 3 significant figures. So let's have a quick look at this one then. Summarize the question here. So part 1 then. So here, find the positive value when f of g of x is 8. So f of g of x is equal to f of g of x, which is equal to f of g of x. And g of x is x squared plus 8. And f sends something to log of something, so that's log of this. And this is supposed to equal the value 8, isn't it? So unwrap the log. So it's log to base e. The e base number comes down, swings down, hits the 8 in the air. So that tells us then that x squared plus 8 is equal to e to the 8. Move the 8 over through the equals, and it tells x squared is equal to e to the 8 minus 8. And then square root both sides, and we just want the positive square root, don't we? So it's the positive square root of e to the 8 minus 8 when we square root. So that's part 1. Part 2, state which one has an inverse. So we just have to state that and define the inverse function. Well, we know that quadratic is a U-shaped curve, so it's not 1 to 1. So the log function will be the one that has an inverse. So f of x is equal to log x has an inverse. So let's work that out. Here, y is equal to log of x. That's log base e. The base number again swings down, hits the y into the air. And we can read from right to left. X is equal to e to the y. So that implies then that f to the minus 1 of x, swap the symbols, y equals e to the x. So there's our inverse function. And it's defined for x for all x in R. And that's because the range of the log function here, the log looks like this. And the range values are the whole of the real outputs, aren't they? The whole real number line. So as the outputs are concerned, that's the range. So the domain will be the same as the range here, which is all of the real number line. So that's part 2 done then. So, and we've got the inverse. Find the value of the gradient of yg of f of x at x value e cubed. Value of the gradient. So let's get y equals g of f of x first then, which is equal to f of x is log x, so it's g of ln x. And g is x squared plus 8, wasn't it? So it's something squared. Something squared plus 8. So there's y. So we need the gradient. So dy dx then is equal to function of function rule here. 2 something to the 1 multiplied by the something differentiated. Log goes to 1 over x. And the constant differentiates to 0. So dy dx equals that. So at the point x equals e cubed then, we need to find out the gradient. Dy dx is equal to 2 log of e cubed times 1 over e cubed, which is equal to 2 over e cubed. And this log of e, well, the 3 comes down, it will be 3 log of e. Log of e is 1, and 2 3s are 6, so it's 6 over e cubed. So that's part 2. Done. So now 3, find the value of, that was part 3 rather, find the value of the gradient at that value. Now use Simpson rule with 4 strips to find f of g of x to 3 significant figures. F of g is here it is here, log n of x squared plus 8 between minus 4 and 4. So this is part 4 now, isn't it? So we need to work out the integral between minus 4 and 4. F of g was ln x squared plus 8, wasn't it? Dx. That was our integral. F of g. Minus 4 and 4. And how many intervals? 4 strips. Simpson's rule, 4 strips to find this value. N is the number of strips. So n equals 4. 4 strips. So there's 5 ordinates. So we'll need to input those. But let's get the formula first. So I've cut and pasted it from the formula booklet. Here it is here. So I'm going to put that just in place here. Now we've got how many ordinates? N is 4. So let's put that in here. Let's do that now. So this is just a formula for Simpson's rule in general. But now we know that n is 4. So this would be 3, wouldn't it? So we go up in all the odds up to y3, and there it is already there. So that's good. And n minus 2, 4 minus 2 is 2, so it's just this first ordinate here, isn't it? As far as this version of the formula is concerned. So that's what we've got then. So we can move that all together now, can't we? So let's put that along over here. And then bring the bracket just in a bit. Okay. Now h for the h over 3 part is b minus a, 4 minus minus 4, which is 8, over the number of strips, which is 4. 8 over 4 is 2. So let's put that in. It was 4 minus minus 4, which was 8, over n, which is 4, which is 2. So let's put that in then. It's 2 over 3. We'll put it in the formula directly. So we're going to need y0 to y4 here. So we'll need x0, x1, x2, x3, and x4. So let's work those out. So what have we got then? We go from 4, from minus 4, in 4 strips. So one would presume that you're going up by 2s, aren't you? So let's go up by 2, because h is 2, so minus 2, 0, 2, and 4. So there they are there. Now we need the y's, so this would be y0 is ln of x squared, 4 squared plus 8, which is ln 16 plus 8 is 24. And y1 is equal to ln 2 squared is 4 plus 8 is 12. And then y2, 0 squared is 0 plus 8 is ln 8. And then y3, now this would be 2. Again, it should be the same as what we had up here, shouldn't it? 8 plus 4, that's 12. That's a good check then, isn't it? And the y4, which we'll squeeze in just here, that should be 24. If you put 4 in, 4 squared is 16 plus 8 is 24. So that's what we've got to put in the calculator. So I equals then. So I'm going to put it in the calculator in one fell swoop. Because it's, well, I'll write it down here hopefully just briefly. 2/3. This, the first plus the last, so it's this plus this, which is 2 log 24. Plus 4 lots of y1 plus y3, that one plus that one. So 4 lots of these, which is 2, so that makes 8. So let's put that down in one fell swoop again. 8 lots of ln 12, because it was 4 times 2 lots of these, and then 2 lots of y2 plus 2 log 8. And that should be it. So we just need to calculate that then. So it's 2/3, 2 divided by 3 times bracket 2 log 24, 2 times ln 24, close that bracket, plus 8 log 12, ln 12, close that bracket, plus 2 log 8, ln 8, close the log bracket, close the bracket for the 2/3 times, and we get 20.262. We need it to 3 significant figures, so it'll be 20.3 to 2 significant figures. And that was to 3 significant figures, sorry. And that was units squared, because it's a measure of area.